guys, welcome back to me, Hannah, here at the Discovery Den. Today we are talking all about hurricanes. What is a hurricane? What causes hurricanes? How do we keep safe within a hurricane? And where in the world do they happen? Dun, 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 dun. Are you ready? Let's get started. Boop. Now, have you ever been in a storm or seen a storm before? Anybody seen a storm? Lightning, thunder. Yeah, how do you feel when you see it? Does it make you feel any certain way? Do you feel excited or scared or nervous or apprehensive, not sure what's happening? Because these storms can be pretty big. Now, here in the UK, we don't experience hurricanes, but there'll be people across the world who definitely have experienced hurricanes before. So what is a hurricane? Does anybody know? Now, anyone who has experienced one or seen one, even heard of one, you will know that it is a huge, fast-paced storm that starts within the on top of the warm oceans and then comes into land, bringing wind and rain with it. And the wind goes a minimum speed of 74 miles per hour, which is as fast as our car on the motorway. So super fast, but that is the minimum speed. So it can go exceptionally fast, almost 200 miles per hour with the extreme hurricanes. So we have been doing several natural disasters. We've talked about volcanoes, earthquakes, tsunamis, avalanches, and now hurricanes. But this one is a little bit different to the ones we've done before. So the ones we've done before are what we call a geological natural disaster. And this type of disaster is based on movement or changes within the earth crust, changes within the earth itself. Which is why we've talked over the last series about the layers of the earth. But this one is not caused by the same thing in the same way. So it's not a geological disaster. It is a meteorological disaster. That's back to front, doesn't help you, does it? But super cool. I was thinking meteorites, but it's not that. It is more to do with the weather. Okay, so the weather creates these natural disasters. I'm going to read this a little bit for you because this explains it better than probably I can. So this is now what we're talking about. So not a geological disaster, but a meteorological disaster. I'm not even sure I'm saying that right. Don't tell anyone. What is weather? What makes it hot or cold or rainy or cloudy? Weather happens in a layer of gases called anyone know what it's called? The atmosphere. Well done if you got that. The atmosphere is like a blanket wrapped around the planet, preventing it from getting too hot or too cold. The bottom layer of the atmosphere is called the troposphere. It contains 80% of the atmosphere's gases and 99% of its water. This is where most of the world's weather occurs. It says here, weather is driven by differences in air pressure. We're going to talk about this today. Temperature and moisture, levels between one place and another. The people who study weather are called meteorologists. Meteorologists use tools including thermometers, anemometers, barometers, and information from satellites to interpret the weather and issue warnings when a big storm is approaching. They like the ometers, don't they? Ometers. And there's a little picture here of our layers of our atmosphere, which is super cool. Now, you know me, I like to get energized before we begin. So we need to get up. We're going to learn a little bit about hurricanes as we move. So come this way, follow me. So we're back here. It's always getting a little bit dark when I do this, when the kids are away. So apologies if the lighting's not great. So there are different parts of our hurricane, and one of them is called the eye of the storm or the eye of the hurricane. And it's right at the center of the hurricane. And if you look at a picture, it looks just like a kind of an eye, a black dot. And in this place of the hurricane, it's very calm, and you could be forgiven for thinking that the hurricane is over. So when I say eye of the storm, you're just going to relax like this, like, woo, this is good. Okay, just relax. We're still going to move a little bit, just keep our body moving, but we're going to relax. If you've got something nearby, you can lie on it, lean on it, okay? So that is the eye of the storm, where the storm looks like it's over, but it is a circle. So remember, it isn't over. Round the eye of the storm is the wall, okay? The eye wall. And this is the area where it is the windiest area, okay? Super top speeds here of the wind. So we're going to be blown around when I say the eye wall. We're going to blow around. Whoa! Whoa! Okay. If I say the eye wall. Remember, when you're in the eye of the storm, the eye wall's going to cross you at some point. So you should never be deceived by it. The next thing we're going to do is the rain band. Now the rain band is where there are sheets of rain. It's towards the outer edges of the hurricane, where it's losing slightly less power, slightly less wind, but you'll have sheets of rain. So we are going to, we're going to take cover. We're going to be on rain like this. Okay, we're going to make the rain come down. So far we've got the eye of the storm where we just relax. Just relax. And then we have the wall, the eye wall, where it is windy. Whoa, watch out. And then we've got the rain bands where the rain starts coming. You can use your fingertips like this for the rain. You can jump up and come down. Wow, however energized you're feeling, let's get that energy coming. And then the next one, I'm going to say, hurricane coming. And we're going to go to the basement as quick as we can. I want to see if we can do this. Oh, it's quite tricky with the legs. Oh my word. So low. So the basement, I can't quite do it, but you're going to make your way down the basement. I love that trick. And then go down. See if I can take a lift. You ready? Is it working? Oh, is it working? It's not quite low enough. Down again. Whoa. Oh, my camera's too high. Okay, so here we go. We've got eye of the storm. Relax. The eye wall. Windy. The rain band. The rain's coming. The rain is coming. Sheets of rain, but less wind. And then we have hurricane coming. Quick, down to the basement. Down to the basement. Down to the basement. Good job. You ready? Now, so I'm going to start by doing it with you. And then I'm going to let you do it yourself, just to see if you can remember. So, here we go. Hurricane coming! Down we go. Whoa! Eye of the storm. Rain band. Whoa. Do your rain, do your rain, do your rain. The eye wall. Here's one of the wind. Hurricane coming. Down we go. Rain band. Eye wall. Remember all the winds. Nice and windy. Eye of the storm. That's where it's nice and calm. Now, I'm going to call out this time without moving. All right, now this is the test where we see whether you are able to remember what I've said. Are you ready? Hurricane coming! Go down, go down, go down. Eye of the storm! Rain band! Yes, you're right. The wall, the eye wall. Windy, windy, windy. Hurricane coming. Quicker, quicker, quicker. Go down. Rain band. Eye of the storm. The wall eye, the eye wall. Ah! Rain band. Eye wall. The eye of the storm. The hurricane's coming. Eye of the storm. The eye wall. The eye wall. Gotcha. Rain band. The eye of the storm. Yes. Hopefully you feel a little bit warmer. You're a little bit revved. Of course, if you want to do that again, just whiz back, do it again, get that energy burning. But we're going to come back to the table. Some super cool experiments today that you can 100% do at home. Some of them you could just watch if you like, or join in wherever you can. Guys, we are back at the table. So we've learned a little bit about certain parts of a hurricane, but now we're going to look at where they happen. So don't worry, we will learn what a hurricane is. We will come to it, or what causes a hurricane. We know what it is, but what causes it. But we're going to have a little look about where we might find a hurricane. Now, some of you may live in hurricane zones. As I say, here in the UK, we do not get hurricanes, thankfully. Now, I have a map with me. And I am going to ask you to see if you can point, I'm going to put it closer, to point to my map where you think I'm talking about. Now just as a top tip, hurricanes begin over the ocean, over warm oceans. They have to be at least 27 degrees Celsius for a hurricane to begin. So like a bath, okay? So they are tropical oceans. So if you know anything about your oceans, that'll be a nice little tip for you. I'm going to give you some more clues. So I'm going to bring towards the camera. Hope you can see it. I hope it's still enough. Okay, so now, hurricanes are called different things. They're called different things in different areas, but they are the same thing. So where do you think they happen? We have here a map. And across our map, well, actually, it's not going across this map, but there would be going across this map a line. Does anyone know what the line would be called? What's the line that goes across our map? It would be called, yes, the equator. Exactly that. It would be called the equator. Now, do you think, hopefully you can see this, do you think that the hurricanes would be happening close or away from the equator? Remembering what I've just said, that a hurricane needs warm water. So do you think they'd be happening close or away from the equator? Yeah, if you said, I'm sorry, I'm making the thing bounce. If you said close to, you are totally right. It would be happening close to the equator. Okay, so in one area of the world, hurricanes are called hurricanes after the god of evil in the Caribbean. So do you know where the Caribbean is? So if you are able to point to the Caribbean on my map, then you, or if you've got a map in front of you, even better, then you would know that in the North Atlantic Ocean, which is, make sure I'm pointing in the right direction, here, we have hurricanes. And also on the other side, the North Pacific Ocean here, okay, right by America. And this is where they are called hurricanes. And as I say, they're called hurricanes after the god of evil, hurricane, from the Caribbean. They are called two other things as well. And they're exactly the same. The only difference is they're in a different location. That's it. So if I show you this, do you know where, is anyone able to point to the Indian Ocean? The Indian Ocean. You point to the Indian Ocean. So I'll give you a second and then I'm going to point. So if you know where India is, kind of going to be quite close. If you don't worry. Here, there he is. There's the Indian Ocean. There's India, the Indian Ocean. This area here is where hurricanes are actually called cyclones. They're exactly the same as a hurricane. They just happen in a different area. Now we have one more area, which is the last area where they're called something slightly different. They're called typhoons. Excuse me. And this is back in that Pacific Ocean, but the other side of it. So we're now going next to China, Russia, that direction. Do you know where that is? If you can see, here's Russia. Here's China, and here is the Pacific Ocean again, and here they are called typhoons. So I'm going to show you another map. If you got any of that right, well done. It's tricky. Oceans are never my strong point. So, and I'm sorry this is back to front, but you can see over here, this is hurricanes over here in the North Atlantic and the Pacific Ocean. And then we have the cyclones in the Indian Ocean and the typhoons back in the Pacific Ocean again, but the other side of it. So well done. So now we know hurricanes start over water, but we don't know much more than that right now. Maybe you do, maybe I'm wrong. But if you're like me, maybe you're just learning as you go. So the question we want now is what causes them, and for that we need to explore something called air pressure. I've noticed I've forgotten something, so watch this space. I will be back in a jiff. Okay, guys, I know that wasn't on for you. I am back. So, we're going to be talking something really important to understand hurricanes is air pressure. Now, all around us, there is air. And even though we maybe feel like we can't feel it, it still creates a pressure. And with enough air, you can feel it. I mean, if you do this, can you feel anything on your hand? Blow for me, blow your hand. Yeah, you can feel the air, right? You're blowing the air towards your hand. So there is something there. And if we look at our bottle, so if you've got a bottle, you can do this at home, and you've got your lid on nice and tight. Now you can see I've got nothing in the bottle, maybe some dregs of water. And if I press it hard, am I able to touch the two sides together? No. Okay. Why? Why? Yeah, because there's air in there, right? There's air in my bottle. So now I take the lid off and I do the same thing. There we go. Look at that. Why can I now press and squeeze my bottle tighter? Yes, the air has shot out of this hole. Okay, so there is something there. There is a presence with air. So now, this is a fun activity that you can totally do with me. I'm going to change my camera view to bring you a little bit closer. Okay, so I have here, I have an egg. I have a jar. And at the moment, does my egg fit into my jar? Is it in there? It's not in there, okay? So at the moment, my egg is just sitting on top. If I do it either way, just sits on top. The air pressure inside the jar is kind of the same or equal to the air pressure outside of the jar. So the egg is just sitting and doing nothing. Now, if I take the egg off and I'm going to apply heat, so I'm going to set my piece of paper alight and I'm going to put it inside the jar. Now, what do we hypothesize? What do we think is going to happen? Because I'm going to put this in my jar and I'm going to place the egg back on top. So what do you think is going to happen? So our hypothesis, we're trying to think what we think would happen with the knowledge we already know. What do we reckon? So I'm going to put this in here, nice and lit. I'm going to put the egg on top. Okay. I want you to have a little think. What happens to air when we heat it up? What happens to air when we heat it up? So this is something just to think about. And let's have a look what happens. Now let's see if this is going to light straight away. Could take a couple of takes. There we go. Here's a light. Oh, hang on. Gonna try again. Try again. Oh, he's nice and warm. But I want him a light before I put him in my jar. Here we go. Okay. Oh, is he still alight? Oh no. Oh no. Okay, we're gonna try again. Oh, he's very light now. Here we go. Here's my egg. Woo! Look at that. Check that out! Where's he going? Is he gonna go all the way? Come on, Eggy. You can do it. Come on, Eggy. You can do it. I see my little one running to come and see. Okay, you will see that the egg, what's happened to it? I mean, this is a pretty small jar. I was a bit desperate getting a jar today. I couldn't find one with a small enough top. He is going inside the jar. And yet a moment ago, he was too big. So how is he now not too big? How does that make sense? Brain overload. The heat inside the jar that we cause with the flame has made the air move around, get very active, and it starts spreading out and expanding, okay? Whoa! And then some of it leaves the jar and it will go past the egg. And then when the light goes out, the flame goes out, the air inside cools very quickly and it contracts. So expand means to get bigger, contract gets smaller. And so as it contracts, it is reducing the air pressure inside the jar. So there is less air pressure inside the jar. There is more space inside the jar. And so the air above the egg now has a higher air pressure and it is pressing down on that egg, pushing it and forcing it inside the jar. How cool is that? So we've changed the air pressure inside the jar to a lower air pressure where the air has contracted. There is less air pressure, a little bit more space, so that now the air pressure on top can push that egg inside with the force coming from above. Now, don't get me wrong, air pressure is in all different directions. It's not just in one direction, this one's going up, this one's going down, every direction, okay? So lots of different directions. Now, we're going to show one more experiment to show air pressure. Again, just in case you didn't quite get it, this one's a fun one. Okay guys, so I'm going to change you a couple of times because I don't think you're going to be able to see very well from this angle, but I will flip you around in a second. So I have a glass kind of tray container, just so you can see. I have a little, it's actually a little dish. The only reason why this is here is so that I can keep my candle that's going to go in the centre out of the water, which I'm going to pour in. So I'm going to do this first bit with you in this view so you can see me, hear me, and then I will change you up. So I'm pouring water into my dish. You don't have to put loads in. And then just for the glorious, beautiful video of today, let's colour it. Let's give it some colour. So I'm giving it some colour. I'm just going to swirl it around. So hopefully, excuse me, you will see, it's very smoky in here now with that. Excuse me, the egg. So you can see I've created a lovely ocean scene for you here. And I have a jar. Now, if you've got any of this at home, you can absolutely do it, or you can just enjoy the visual of it here. Now, once again, I want you to have a think. So this is very similar, showing us the same as the egg experiment. Why am I doing it again? Because the more visuals we have, the more we go, oh, I did that. I remember something about this. The more later on it comes back to us. So I am going to light the candle and I'm going to put the jar on top. And my question is, what do you hypothesize? What do you think is going to happen? Apart from a super cool, awesome experiment. So we know the candle is creating heat. We know inside the jar is what? Nothing? Is there anything in there? Looks like nothing. Are you sure there's nothing in there? Yeah, air. Air is inside this jar, whether we can see it or not. And then we've got water down here, but also all around me here, what is there? Air, okay? Air again. With all those things in mind, you have a think what you think is going to happen while I move the camera a little bit closer, and then we'll see and observe what does happen. Okay, so we're back. A little bit of a closer view. Hopefully you will see it fantastically. I've got my lighter. If you're doing this at home, please make sure there is a parent to help you. Kids, don't do this on your own, especially when you're dealing with the fire and the flames. If anything goes wrong, you need a parent present. Excuse my arm coming through the view. I am going to light the candle. Okay, so we have got the heat. We've got the heat going. Let's get my jar and let's see what happens. I don't know if you heard that. The little bubbles were just leaving the jar. Now, right now, what is happening to the air inside the jar? So with the candle inside, what is happening to the air inside the jar? Yeah, the air is heating up. So inside our jar, our air is heating up. And so what's happening to the air? Yeah, it's expanding, it's moving around more, it's taking up more space, okay? And it's rising as well, okay? So it'll be rising, always hot air rises, classic. Now, my candle's about to go out and I want you to see what happens, because as that candle goes out, here we go, ooh, there's the blah, blah, blah. As that candle goes out, the air is now becoming colder, is becoming restricted or constricted. So it's getting tighter together, creating more space, creating low pressure inside our jar, a higher air pressure outside, and it now wants to flood its way into the jar, forcing and pushing the water inside the jar as well. So low pressure inside, high pressure outside, means that that water ends up going inside. Now I'm going to do this on a slightly bigger scale, so you can see it again. Why not? Let's just keep going. Okay, so here we go. Same tray, but now this time I am going to put a bigger candle. So hopefully you can see here. You don't need to be looking at there. Don't need to see me. And I'm going to light this candle. Hopefully it'll light, because it got a bit wet earlier today when I was doing a little practice run. Here you go, it's fine. And I've got a slightly bigger jar, but the jar is a different colour. But I hope you can still see the same effect. So, what do we think is going to happen? We should know by now. We're going to, oh, he's going out, hang on. We are going to create low air pressure inside the jar, and it is going to create high, or there'll be high pressure outside the jar, forcing, oh, let's get this on. Oh dear, dear, dear. Do you know what? I might actually just do this as well. Oh, there we go. Oh, now don't do this at home. Don't burn yourself, please. I'm putting this in too to get a bit more. Will that work? Should we do it? Let's go. Okay, there's the bubbles of releasing some of the oxygen, releasing some of the air. And now we are warming up. I'm hoping it's warming up the air inside. And we're preparing to see when those lights go out, when the flames go out, what happens next. Well, we know what happens. We know that it creates low air pressure inside the jar, because right now the air is heating up, it's super warm, it's expanding, and then as soon as it cools, it will constrict. What word did I use a minute ago? Did I say constrict or did I say constrain? I'm not even sure. But it constricts, okay? So it closes up, it tightens up. So here we go. The candles are going out because the candles are losing oxygen, so the flame can't continue. And here we go. Here's the rise. Can you see the rise? Here we go. Keep watching at the bottom there. I know it's slightly harder with this. Can you see it going up? So the air has cooled down. The water has risen, being forced in by the air pressure outside. Cool, huh? So now I'm going to take off my jar. Ooh, it's going to pop. Ready? And I'm going to move this to the side. Okay, guys, so what does this have to do with hurricanes? I will show you. So hurricanes happen above the ocean. Okay, so here's our beautiful ocean. Now the ocean has to be at least roughly 27 degrees Celsius in order for a hurricane to happen. So the sun is warming it up. Okay, a lot of hurricanes happen in the Philippine areas. So there you go, we have the sun warming up our ocean. And then what happens is, as the sun warms up the ocean, the air also gets heated, okay? And the air starts to what when it gets warm? What does air do when it starts to get warm? Yes, it rises, okay? So it starts to go upwards, leaving an area down here of low pressure, okay? Low air pressure, which means what does the rest of the air want to do? Yeah, it wants to go and fill it up, basically, okay? Because now we've got high pressure out here, high air pressure out here, and we've got low air pressure here. And so now this outside air now wants to come into that point. But the cycle continues. So this air now gets warmed up and it also goes up. So this is the new set of heated air is now going up. So continuing to keep this as a low air pressure area. And as the air goes up, it starts to cool and they get pushed to the side and they start forming clouds. And they're getting pushed to the side by, the hot air that's rising, okay? And this is a continual cycle. And these clouds here, in order for these clouds to stay there, there has to be not strong winds at this point. There has to be a fairly steady wind. And if there is a steady wind, it keeps the clouds close together. And as this cycle continues, we build, or the world builds more and more clouds that stay together and creates a bigger and bigger thundercloud. And now, because as this air is rising, it's very humid. It's carrying water droplets with it. So it's taking water up with it, creating those clouds as it cools, creating those clouds also full of rain as it cools down. And as these stay together, you start to get this incredible kind of swirling motion of a hurricane. And that swirl, which we're going to have a little look at, is caused by the way the earth moves, the turn of the earth, and this builds up stronger and stronger winds. And when those winds hit 74 miles per hour, we now start to classify it as a hurricane. And I'm going to just show you here in my... Let's have a look what a hurricane would look like as we do the spin. Now, it would be great if you can have a little look on Google, look at some hurricane pictures. Yeah, there's some awesome pictures of hurricane on Google, these lovely swirling movements. But I'm going to show you here. Once again, I'm going to bring it a little bit closer. I'm actually going to move you with me this time. Okay, so here we are, guys. I was going to move you with me, but it was looking disastrous. I thought I might drop my phone in the water. And now, so we're going to start to get this lovely swirling motion. Remember, we're on top of the ocean here with this hurricane. You can do this at home. This is so simple. Have a bowl, get some water, and then just start to turn it with a spoon. And then what I'm going to do is you can see what's happening. Let's see if this works. So I'm just doing a little droplet into my, let's try a couple. There we go, there we go. And can you see that we're getting that lovely spinning motion, which would be exactly like a hurricane. We have the rain bands on the outside, which would be where there is a reduced amount of winds from the hurricane. The eye of the hurricane would be right in the middle where it's that nice, clear, relaxed state. And then you would have the wall of the eye. Now I'm going to mix this all in. Let's see if we can do it one more time, but this time with a different colour. Let me just grab a different colour. And we'll see if we can get that same effect again. So this lovely swirling motion, this is what our hurricane starts creating, starts building up all the clouds. Here we go. Let's try with this. Come on. Oh, look at that. Oh, I think that was a good one. Is that a good one for you guys? Did you see that? Can you see that swirling movement as it goes round and round? Look at that. I mean, we're changing the water purple now, I appreciate, but this is the motion that you would get from your, from the hurricane. So the next question is going to be, what damage do hurricanes do? Okay guys, so what do you think is the damage that a hurricane does? What do you think the type of damage a hurricane does? So I'm going to read a little bit for you, but I want you to have a little think. So we've said that a hurricane is created over an ocean due to the change in air pressure in a low air pressure area that's creating the air to move up, rise, cool, creating these clouds alongside the wind at the right speed to create this hurricane. But as this hurricane continues to energize itself with the hot air from the ocean, it will move, and it moves inland. And as it moves inland, the pressure of the, or that cycle of warm water rising, moving, forming clouds starts to stop, or stops, because it's not over the ocean anymore. So as it moves inland, it will now start to kind of die off, but not quickly enough to not cause damage. And as it first moves inland, something can happen called a storm surge. And what happens is it takes a load of the ocean, a load of water with it onto the land, and basically blows that water across land for up to 100 miles. Which, as you can imagine, can cause all sorts of damage. And most people die in the storm surge where they dive from the flood. So that creates mass flooding. Okay, and the rain it can rain up to 50 centimeters like at a time. So this is like, I don't know, that much, if I'm being accurate enough. So there's a lot of water suddenly, and this is where people, suffer from this. Now, other things that can happen. Okay, so this says tropical cyclones can dump over 50 centimeters of rain within just 24 hours. That's not a lot of time at all. So that is a lot of flooding going to happen in homes. Another concern is actually disease. And the standing water left after a big flood can lead to disease like cholera and mosquito-borne diseases like malaria. So when that water doesn't go anywhere, there is nowhere for that water to go because everything is flooded. It sits and it stagnates. Now, if anyone's ever had some stagnant water in their garden in a nice kind of humid summertime, you will probably notice lots of little things inside it and flying out of it, which are mosquitoes. So in certain areas, malaria is a big problem, which is carried by mosquitoes. So this could be a big issue. It also says small tornadoes can develop inside the eye wall of a hurricane. Sometimes it's hard to tell what damage is caused by the hurricane and what is caused by the tornadoes. We're going to be doing more about tornadoes in a few weeks' time. But the tornadoes and the hurricane, the wind, the size of the winds, the speed of the winds is going to knock anything down in front of it. Turn over cars, break buildings. Okay, huge amounts of damage here. They're going at such high speeds. Now, so in an event of a hurricane, what do you have to do? Okay. Now, ideally, if it's a very extreme hurricane, you need to evacuate. So I've got a little final game for you. Let's see how you get on. So my final game is, I am going to give you some items that you need to find in your house as quick as possible to see if you can evacuate this hurricane in time. Now, hopefully you have some of these items in your house. Some of them are essential, some of them are not really essential. It's just for a bit of fun. But if you were in a hurricane, you'd have to pick up your essential items, pack them, and go. Let's see how quick you are at packing. Are you ready? Can you go and find your favourite teddy bear? Go! If it's not a teddy, it could be a toy. It could be something to give you comfort on your route. Okay? If you're slightly older and that is, I don't know, whatever keeps you comfort. A book could be. Okay, go find it. Go, go, go. Wherever you are, run, run, run. I'm going to give you 5 more seconds. 5, 4, 3, 2, 1. Are you back? Are you ready? Because here's the next one. The next one, you have to go and find a bottle of water. If you can't find a bottle, go find a glass. Go, 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 go find it. Go, don't just sit there. Go, don't just look at me. I can see you just sitting there. Go, go, go. Otherwise I'll start singing and that means it will all go wrong. Horribly wrong. See, you won't even want to come back. 5 seconds. 5, 4, 3, 2, 1. Are you back? Okay, ready. Next one. Now this one's going to be a tricky one because you might not have one in your house. Although if parents have got a phone, you've all got one. Can you find a torch? A torch. A torch, a torch, a torch, a torch, a torch to shine a light. Anything that shines a light. Go! Go, 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 go. Sorry, I'm very loud. And there's a lot of singing going on. Go. I feel like we need music like da 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 da. That's always like the countdown, like the end. Do 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 do. Ba da 3, 2, 1. You're back. Are you back? I hope you're back. Okay, let's give you one more. Okay, your last one. In order to go on this evacuation journey, you need a snack. So go to your kitchen, go get a snack, bring it back here. Let's see. Ready, go. 10. We've got 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. Yeah! Hopefully you all got your evacuation essentials, things you might need in a real evacuation. hello phone charger, your phones, any important documents, water, nibbles. But at the end of the day, if the storm is that bad, just get out. Listen to the safety office. They will tell you what to do. Guys, you have been amazing. I hope you have enjoyed this session. We have learnt what a hurricane is. A hurricane is. We have learnt what causes hurricanes, including air pressure. So you can now hopefully explain what air pressure is. We have looked at where hurricanes happen and also how to keep safe in a hurricane. You are rocking it. This is our natural disaster series. We have a couple more sessions coming up, but there's going to be a little bit of a break before they come. So watch this space. Please don't forget to follow, like, subscribe, do all of that stuff to keep us bringing fresh, free content for you at home. Until next time, peace out.